Hi, welcome to today's class. And in today's class, we'll be unlocking a powerful mathematical shortcut called indices or exponents. Indices is a plural form of index, also known as power, and it is used to solve the problems of writing out incredibly long numbers. Look at 2 raised to the power of 5. It doesn't mean 2 times 5. This little number, the index or power, 5, tells the big number, the base, 2, to multiply itself repeatedly. Indices are critical because they let us use simple rules to handle complex multiplication and division. In this video, we will learn these few simple rules that govern all of mathematics. So without further ado, let's dive in and start getting our hands dirty with calculations, and I'm sure you will love it. So the next one is to talk about the rules of indices. I know when you go online, you must have seen a lot of mathematicians trying to demystify indices. But what I think you should know first is the rules of indices. What are the rules of indices? Here I've listed 8 rules of indices. The first one is the product rule, the second, the quotient rule, the third, the power of the power rule, the fourth, zero index rule, the fifth, power of the product rule, the sixth, power of the quotient rule, the seventh, fractional index rule, and the eighth, negative index rule. So these are the rules we apply when solving INDICES questions. So the first one is the product rule. The product rule. Product rule, also known as the multiplication rule. Product is the same thing as multiplication, sum is addition, quotient is division, and difference is subtraction. Good. So it says that when we multiply the same base, we add the powers. So a raised to the power of m multiplied by a raised to the power of n equals a raised to the power of what? M plus n. These are the bases, right? And these are the powers. So we take one of the base, we add up the powers, m plus n. That's the first rule, which is the product rule. Now, an example of this is we have 2 raised to the power of 3 multiplied by 2 raised to the power of 4. That will give me 2 raised to the power of the powers, which is 3 plus 4 equals 2 raised to the power of 7. And as we know, 2 raised to the power of 7 equals 128. That means we are multiplying 2 in 7 places. So 2 multiplied by 2 multiplied by 2 up to 7 times. So it is not the same thing as 2 times 4, 2 times 7. 2 times 7 is 14. So it's not equal to 128. Let me take another example. If I have 2 raised to the power of minus 3 multiplied by 2 raised to the power of minus 2. Since the law is stating that we are going to add up the powers, so it's going to be 2 raised to the power of minus 3 plus open brackets the power of this minus 2. That's 2 raised to the power of minus 3 plus multiplied by minus. That will give us minus. So minus 2. Therefore, our final answer is 2 raised to the power of minus 5. That's for product rule. And the next one I'll be talking about is the quotient rule. Quotient rule. Quotient is the same thing as division. Number 2, quotient rule. Quotient rule, the same thing as division. It states that whenever we are dividing the same base, we subtract the powers. So a raised to the power of m over a raised to the power of n can be written as a raised to the power of m divided by a raised to the power of n. And that equates a raised to the power of m minus n. Whenever we are dividing the same base, we subtract the powers. So an example of this is if I have 5 raised to the power of 4 divided by 5 raised to the power of 2 is the same thing as 5 raised to the power of 4 divided by 5 raised to the power of 2. So that will give me 5 raised to the power of 4 minus 2. And that is the same thing as 5 raised to the power of 4 minus 2. The answer is 2. And what is 5 squared? It is not 5 times 2. It is 5 multiplied by 5, which is 25. Now let's take another example. If I have 3 raised to the power of minus 3 divided by 3 raised to the power of 2, how can we get an answer? So this is going to be 3 raised to the power of minus 3. Since division states that we are going to subtract powers, is going to be minus 2, right? So that will give us 3 raised to the power of minus 5. Let me take one more. This is going to be 3. Okay, don't let me use 3. Let me use 4. 4 raised to the power of 5 divided by 4 raised to the power of minus 2. Good. That will give us 4 raised to the power of 5 minus open bracket, because this is having a negative sign. So it's going to be minus 2. And that will be 4 raised to the power of 5 plus 2. Minus times minus, that will give us plus. So 5 plus 2, that's 4 raised to the power of 7. That is for quotient rule. So the next one we are going to be talking about is the power of a power rule. Power of a power rule. So power of a power rule states that whenever we are multiplying a number with a power by another power, the powers are going to multiply each other. So number 3 is power of a power rule. So if you have a raised to the power of m, all in brackets of n, so that will give us a raised to the power of, we multiply the powers, m times n, that's a raised to the power of m times n is mn, right? So let's take an example. If I have 5 raised to the power of 2 bracket 3, that will give me 5 raised to the power of 2 multiplied by 3. That is 5 raised to the power of 2 multiplied by 3. That will give us 6. Let me take another one. If I have 2 raised to the power of minus 3 in bracket of let's say 4, then I'm going to have 2 raised to the power of minus 3 multiplied by 4, and that is 2 raised to the power of minus 12. That is for power of a power rule. The next one is zero index rule. Zero index rule. Zero index rule. Number 4, zero index rule. This says that when a number, a non-zero number, is raised to the power of 0, the answer equals 1. Okay, a raised to the power of 0 equals 1, such that a is not equal to 0. So that's why it is very wrong for you to say any number raised to the power of 0 will give us 1. Yeah, if you say any number raised to the power of 0 equals 1, it is incorrect, because 0 is a number. Therefore, 0 raised to the power of 0 cannot give us 1. It is only numbers that are non-zero. Are you with me? Good. So this is as simple as ABC. If I have 5, an example is 5 raised to the power of 0. An example here, if I have 5 raised to the power of 0, that will give me 1. Even if I have 100 raised to the power of 0, it still give me 1. If I have AB, all raised to the power of 0, the answer is 1. So as far as it is a non-zero number, it is what? Equal to 1. That is for zero index rule. So the next one is power of a product rule. Power of a product rule. That is number 5. Number 5 is power of a product rule. Product rule. Oh, so this is the law. When we have a, b raised to the power of n, they are multiplying each other, right? A times b, all in bracket of the power. So we can distribute the power to have a raised to the power of n multiplied by b raised to the power of n. So which is equal to a n b n. That's for power of a product rule. Okay, let's take an example. If I have 2 multiplied by 3, or let's say 2 multiplied by p, all raised to the power of 3. So that will be 2 raised to the power of 3 multiplied by p raised to the power of 3. And that will give us 2 raised to the power of 3, that is 2 multiplied by 2 multiplied by 2, which is 8, multiplied by p raised to the power of 3. Therefore, our answer is 8p cubed. That's how the power of the product rule works. So the next one is the power of the quotient rule. Power of the quotient rule. Power of the quotient rule. That's number 6. Power of a quotient. Power of a quotient rule. So quotient means division. If I have a over b, all raised to the power of n can be distributed to give us an over bn. As simple as that. So let's take 7 over m raised to the power of 2. That will be 7 squared over m squared. And what is 7 squared? 7 squared equals 49 over m squared. And that is our answer. So the next one is to take the fractional index rule. You need to pay attention. So number 7, fractional index rule. Fractional index rule. So the first rule, number 1, a raised to the power of 1 over n equals n root a. That's the first one. So let me take an example here. E.g., if I have 2 raised to the power of half, that will give me root 2. Or if I have 4 raised to the power of half, that will give me root 4. And the square root of 4, because 4 is a perfect square, the square root is going to be 2. So the second rule is a raised to the power of m over n. So that will give us, we can write it in 2 instances. The first one is n root a m or n root a, all in bracket of m. Let's take an example. If I have 8 raised to the power of 2 over 3, that will be 3 root 8 squared, or we can write it as 3 root 8 all squared. So the answer to this is 3 root 8 squared is 64. 8 squared is 64, or 3 root 8. That tells us that what number can we multiply 3 times to give us 8? And that number is 2. So we still have square outside, 2 squared. Therefore, the answer to this is, what number can we multiply 3 times to give us 64? The answer is 4. And for this also, 2 squared equals 4. So this shows that any method you are applying, either this or this, you are still going to get the same answers. Alright, that is for fractional index rule. The next is the negative index rule. Negative index rule. Negative index rule. Number 8 is negative index rule. So the first rule is 1, okay, a raised to the power of minus n. The negative index rule is going to be 1 over a raised to the power of n. So we've changed this negative power to positive power by introducing 1 divided by that base and its power. So an example is, e.g., if I have 2 raised to the power of minus 2, that will give me 1 over 2 raised to the power of 2. And the answer is 1 over 4 for that. So the next one here is, if I have something like this, 1 over a raised to the power minus n. We can change this back to a positive power by taking it up. So it's going to be a raised to the power n. If I have, e.g., if I have 1 over 3 raised to the power minus 2. That can be written as 3 raised to the power of 2, which is equal to 9. That's 3 times 3. It is not the same thing as 3 times 2, because 3 times 2 equals 6. Good. The last but not the least here is I have a raised to the power b, a over b raised to the power of minus n. Now the shortcut method is to just move this up and take this down, then the sign will change. It is going to be b over a all raised to the power of n. I know you are confused. Now let's explain what I have here. Let me erase this part. Okay, erase this too. I want to explain this. We have a over b raised to the power of minus n. From the power of the quotient rule, yes, we can distribute the power a raised to the power of minus n over b raised to the power of minus n, right? So I can write this as a raised to the power of minus n multiplied by 1 over b raised to the power of minus n. It's still the same thing, because if I have a negative power, if I multiply this by a multiplied by 1, I'll still have this initial fraction. So what to do now is, I want to use the negative index law to change this to a positive power. That will be 1 over a raised to the power n, right? Multiplied by the second law that I wrote. So if I take this off, it's going to be b raised to the power of n. Therefore, the final answer, if I multiply this by this, I will have b over a n n. So the last but not the least is to write both in a fraction and put the power here, just like the origin. So you can see that it is the same thing as what we have here. So therefore, instead of going through this long process, you can just swap it and change the power. It's as simple as that. So let's take an example on this. This question, if I have 4 over 3 raised to the power of minus 3. So I will just swap it. It's going to be 3 over 4 raised to the power of 3. That is 3 cube over 4 cube. What's 3 cube? 3 cube is 27. That's 3 multiplied by 3 multiplied by 3 divided by 4 cube. That is 64. That is 64. So that is our answer. It is as simple as that. Thank you. Thanks for watching. If you have any questions or topics you would like me to treat in future videos, kindly leave them in the comment section. Remember to subscribe, like, and share with your friends for more content. Thanks once again. My name is Professor Black.